all you Gretas and Shutezcats out there. Welcome to 8 Notes Unit 4, Section 7. We're going to look at solar radiation, the sun, and Earth seasons. So here we go. Here's a nifty little graphic. If you hate cold and hate heat, where you might want to live. If you hate cold and love heat, love cold and love heat, or love cold and hate heat. You are crazy people. I'm over here. I need my warm weather. I'm already missing the summer. All right, so how many ways does the Earth move? It's actually 3. So we have factors that affect the amount of solar energy at the surface of the Earth, which is directly correlated with how much plants can produce. So one, we have rotation of the Earth, spins in a circle. We have revolution, one a year, so we're going around the sun. We have the tilt of the axis. The Earth is at 23.5 degrees, and we have atmospheric conditions. So we have our 3 ways the Earth moves and then various atmospheric conditions on top of that. So what causes the seasons? So summer occurs in the northern hemisphere when it is tilted towards the sun, the Earth, and the sun is going to rise higher and stay above the horizon longer. The rays are going to strike the ground most directly. Seasons are not caused by Earth's distance from the sun. So it's the tilt that causes the seasons. So the tilt of the Earth causes the seasons. So when the Earth is tilted away, when the northern hemisphere is tilted away from the sun, we have winter. And Australia and down south is going to have their summer. So when we are celebrating Christmas and we're all bundled up, Australians are in a tank top and shorts and flip-flops, grilling their shrimp on the Barbie, celebrating Christmas. And so then when the northern hemisphere, when the Earth is tilted towards the sun, that's when we have the summer solstice. So we have summer and then they would be cold. So June, July, and August for Australia are going to be their cold months. So we're going to look at Bill 9, if it lets me.
The season. It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year. The reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth, and there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now not only is the Earth going around the sun, but the Earth is spinning. Now when you're on the part of the Earth that's toward the sun, it's daytime. And when you're on the part of the Earth that's away from the sun, it's nighttime. Now the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the sun, it's summertime there. So when it's summertime here at Nye Laboratories, on the other side of the world, it's wintertime in places like South America and Australia.
Hey, Bill, your shoes untied.
Oh, thanks. Then, when the part of the Earth that we're on is tilted away from the sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because the Earth's axis is tilted. That's the reason for the seasons. Why are the North and South Poles the coldest places on the Earth? Well, please consider the following. Let's say that this heat lamp is like the sun, because it's hot. And let's say that this globe is like the Earth, because it looks like the Earth. Anyway, we've mounted thermometers on the Earth like this. See? Now, the one at the equator is just about off the scale. And the one at the South Pole is right around the room temperature mark. And the ones in between are somewhere in between. That's because the heat is hitting the one at the equator almost straight on. Whereas at the poles, it's just barely grazing by. And then somewhere in between, well, it's somewhere in between. See, it's not that the equator is closer to the heat. It's that the heat is hitting it more straight on. See, if the Earth were sitting like this, then this thermometer would be the hottest, and this one would be the coldest. Anyway, that's why the very warmest places on the Earth are right around the equator, tropical rainforests and jungles. And the very coldest places are at the poles, because they're the ones that the energy from the heat lamp lamp just barely grazes by. I mean the energy from the sun. Thank you for joining me.
Do you notice, though, that the axis about which the Earth turns is not straight up and down? It's tilted to one side, at an angle of 23.5 degrees from the perpendicular. This has a lot to do with why we have different seasons, as we shall see.
Let's say that this plastic globe of science is like the Earth, and we have two solar panels mounted on it. Now, solar panels convert light directly into electricity. So right now, these two panels are making enough electricity to run these two little motors. Now, right now, both motors are going about the same speed. Now, notice that we have one panel in the northern half of the Earth, the northern hemisphere, and one panel in the southern half of the Earth, the southern hemisphere. They're both receiving about the same amount of light. But let's say it's summer here at Nye Laboratories in the northern half of the Earth, the northern hemisphere. That means that the Earth would be tipped toward the sun about like look, the motor in the southern hemisphere is just barely moving, and the motor in the northern hemisphere is spinning like crazy. Now let's say it's 6 months later, and the Earth has gone around the sun so that its axis is tipped this way. Now look, it's reversed. The one in the south is going wild, and the one in the north is slowed way down. See, what that means is this panel in the southern hemisphere is receiving more light, more energy from the sun than the one in the northern hemisphere. It's just like the Earth's seasons, right here with the solar panel plastic globe of science.
Using a flashlight, you can see for yourself that direct rays are concentrated on a smaller area than slanted rays. This is why direct rays produce more heat.
Alrighty, so hopefully Bill Nye explained that stuff to you. And let's come back. Go. All right, so weather. Short-term set of short-term atmospheric conditions, typically those occurring over hours or days for a particular area. What's going on outside right now is weather. Examples of short-term atmospheric conditions: temperature, that changes daily, that changes over the course of the day. Pressure, moisture content, precipitation, sunshine, cloud cover, and wind direction and speed. So all of those things can change very, very quickly here in Indiana, every minute, hour. But weather is very short-term. Climate is an area's general pattern of atmospheric or weather conditions measured over long periods of time, ranging from decades to thousands of years. You need at least a 30-year average to indicate a climate. So here are the climate zones of the continental United States. So we are in the area of, we've got warm summers, cool winters here. Down here, they definitely have more warm all year round. Crazy Floridians. They have a nice Mediterranean climate over here, and this is where it snows. So these are climate zones, but obviously it changes, and we can have some freaky weather from time to time. And then weather is, what is it doing today? I like this quote: climate is what you expect, weather is what we get. And with that, you have finished this round of notes. So before I go, I'd like to take this opportunity to tell each and every one of you that you are good enough, you are smart enough, and people do like you. And in case I don't see you, good afternoon, good evening, and good God, do your homework.